The project CART, that stands for Cooperative Autonomous Robotic Towing System, proposes a new concept of salvage operations of distressed ships at sea. Coordinated by Serena Ardito, a young woman entrepreneur, the CART project was founded by the FP7 Programme Research for the benefit of SMEs in the period from November 1st, 2011 to July 31st, 2013. The consortium is constituted by 3 SME participants. The project coordinator, Posidonia SRL, an Italian SME based in Genova, providing towing and marine equipment. PKL AS, a tugboat company from Tallinn, Estonia, providing towage and salvage services within its own fleet. SRS Mecano Installii, a small company from Bucharest, Romania, moving from the field of electrical installations to the area of industrial automation. The 3 RTD developers. The Institute of Studies on Intelligent Systems for Automation of the Italian National Research Council from Genova. Department of Control and Computer Engineering of the University of Zagreb, Croatia. Norse Veritas from Oslo, Norway, one of the world's leading classification societies. The CART concept is based on the development of robotized unmanned marine platforms able to semi-automatically or automatically execute the high-risk operation of linking the emergency towing system of distressed ships to towing vessels. This will minimize the risk of human lives and increase the safeguard of the environment, helping, for instance, to prevent oil pollution at sea during salvage operations. The key idea consists in collecting a floating object at sea by executing a knot around it with a floating rope. In our case, the floating object is a buoy launched by the distressed ship, while the knot is executed by an unmanned robotic vehicle towing the floating rope connected to the tugboat winch. 2 main scenarios have been considered involving harbour and open sea operations. The first scenario considers the case where a tugboat needs to tow a burning ship, typically a tanker in an oil terminal, out of a harbour. The CART vessel has to recover a buoy nearby the moored ship. The second scenario considers the case where a tugboat needs to recover an emergency towing system deployed by a distressed vessel in open sea. The CART vehicle, that is an intelligent emergency towing system, has to move away from the distressed vessel in order to be recovered by the tugboat in safe conditions. An extension of this case considers a scenario where a ship in distress is rescued by another ship. In this case, a second CART vessel automatically executes a knot around the intelligent emergency towing system. To demonstrate the feasibility of the CART concept, a set of prototype unmanned semi-submersible vehicles have been developed. The development and test for the first prototype focused on the validation of the rope hooking system and on the effectiveness of the knotting maneuver. It also supported the experimental evaluation of the motor thrust needed to counteract wave effects in operating conditions. System integration tests were carried out in Murter, Croatia, during Breaking the Surface in October 2012. Preliminary field validation was performed in Tallinn, Estonia in November 2012. At first, tests demonstrated the effectiveness of the hooking system in catching a floating rope. Then the harbour scenario was considered, where a floating buoy was deployed at sea nearby a moored ship. The CART vehicle, remotely controlled by a human operator through a radio communication link, was able to recover the floating buoy, thus validating the effectiveness of the hooking system in numerous experiments. Finally, the system capability of recovering a floating buoy in open sea was satisfactorily verified, completing the validation of the CART concept. In-field deployment and recovery of the vehicle from a tugboat supplied information about the target shape and weight of the robotic platform in order to make it easy to handle in operating conditions. The last year of the project was devoted to the design, development and test of 2 new prototype light and manageable unmanned semi-submersible vehicles. Moreover, robotics research focused on the design and implementation of suitable cooperative knotting maneuvers. System integration and maneuvering validation were carried out during a test campaign in Geneva Praia Harbour, Italy, in May 2013. The vehicle, acting as an intelligent buoy, autonomously moved in a straight line, simulating the deployment from the distressed ship. The recovery vehicle autonomously executed a couple of circles around the intelligent buoy, on the basis of its GPS position received through a radio link. During the final demonstration in Tallinn, Estonia, in July 2013, the CART cooperative maneuvers were validated in operating conditions in both harbour and open sea. Harbour trials verified the effectiveness of the new designed vehicles in recovering a floating buoy being remotely operated in protected waters. Extended tests of the autonomous knotting maneuver involving both the vehicles were carried out, even exchanging the robot roles in view of the final demonstration. Open sea trials were supported by 2 tugboats, one acting as distress ship and the other as rescue tugboat. The intelligent buoy, once deployed at sea, moved away from the simulated ship in distress. Then the recovery vehicle was launched by the salvage tugboat and executed the knotting maneuver. Once knotted together, the vehicles were recovered on board the salvage tugboat by pulling the towing line. The project field activities ended with training of the tugboat crew to remotely pilot the CART vehicle through its control console. As a result, the new CART robotic-based technology for the recovery of emergency towing systems has been qualified, and the involved SMEs can plan follow-up activities of engineering of a cheaper prototype